Well, maybe I'll start with the intro. I'm Francesco Liucci. I'm working for ESA, and I'm the manager of the Business in Space Growth Network accelerators. And in particular here, I'm presenting this panel on dual Earth and space use cases in regards to the accelerator that we have at ESA for space resources. I'm quite excited because effectively here we have 5 of the 6 companies that we are supporting in the first cohort of this accelerator. And just to give you an idea of what we do, the accelerator is an initiative from ESA to support the development of the entire value chain of space resources for lunar applications. And the model is pretty straightforward. ESA provides 50% of the funding towards what we call implementation plan. So we ask the company that we select to commit towards a meaningful demonstration of their technologies and their commercial solutions at this stage on terrestrial ground, and effectively helping them to move and mature towards the end goal, which is the demonstration in lunar environment and then the full commercialization. So I'll introduce now a little bit more about the topic. I'm quite passionate about this topic, the dual use case of Earth and space, or in other cases, low Earth orbit and lunar. And looking from a little bit of a historical perspective, although we are dealing here with a relatively novel field, space resources for lunar application, I have the feeling that the topic and the focus of having businesses that have an application on Earth and an application on the Moon has been, in particular in the first stage of evolution, also a way to create a narrative that was a little less scary, a little more short-term, more inviting for investors, more inviting for companies and entities that were approaching to this new field, and trying to communicate them that, yes, there are companies that are building solutions for the Moon, but there are applications that can happen earlier and that can have a revenue-generating venue that can happen in the shorter term. But over the past few years, we've witnessed some maturation and evolution of this. In general, the entire ecosystem is growing. So I think it's a good time to have a discussion about this, because I have the feeling that there is a little bit more of an honest point in dealing with these dual cases. We are dealing really on the real challenges of having businesses that have a perspective on application that they can be used in different markets. And I'm quite glad to have the companies of the BSGN Accelerator to be able to talk a little bit more about this. So without further ado, I'll start with the first question, which is really just to warm it up. So I would like to ask each of you to present yourself, your company, and what the company is doing. So in which way you're positioned in this conversation related to the dual use case. Maybe we'll start with FiberCode.
Thank you. Yes, so I'm Robert from FiberCode. Some of you might have seen me just before. We make fibers, high-performance fibers, at a very low cost. That's what we set out for to do. We have applications on Earth where we coat glass and basalt fibers that we make ourselves with metals and polymers to then be used in EMI shielding for construction, for automotive, a lot of defense that we do in that area. And we've been transitioning into the space sector where we use the same materials that we make on Earth for satellites, for example, to reduce the weight and decrease the service lifetime with better shielding, as well as stepping with the accelerator into the manufacturing of fibers from moon regolith on the Moon itself. So we have an established business on Earth where we provide our fibers to terrestrial applications, and we are now stepping into those space applications where we see growth and interest in both areas.
Thank you.
Thank you. I'm Jakub, CEO and co-founder of Orbital Matter. We are a space construction company. We are minimizing payloads that are launched on rockets to space, because we're launching only 3D printers with raw material. and we enable creating structures in space without any limitations in size and its shape. Well, there's one limitation, the amount of raw material that we have on board. So far, we developed a threshold prototype of the printer. Initially, it is designed to be a satellite component. This is our first product. We want to miniaturize deployable systems on the satellites, eventually scaling down the whole platforms to save money on the components, save money on the satellite cost and on the launch cost. Regarding Lunar Accelerator, Space Resources Accelerator, we want to adapt our printer to work in a lunar environment, starting also from the simple use case, the same as on the satellite, to provide much more efficient deployment mechanism based on our 3D printer. But the long-term perspective is to provide a universal tool, universal platform for lunar construction. And the same plan is for the Earth orbit and beyond. Thank you.
Hello? Does this work? Yeah. Okay, cool. So I'm from Orbit Fab. I'm the business development manager there. So Orbit Fab, we do in-orbit refueling of satellites. So essentially what that means is what we want to sort of reduce is that single-use paradigm of satellites. Currently, if satellites run out of fuel, they kind of become space junk. What we want to do is extend the life of that asset for longer up in space, continue having that generating revenue up there for longer. So this, I always bring this as our little friend. This is Rafty, our interface. So if your satellite is equipped with one of these, then we'll be able to come refuel you in space. So our low pressure, so hydrazine chemical propellant, is actually qualified. And what we're doing in the UK is developing a high pressure variant, so for electric and green propellants, so things like xenon and stuff like that. So that's going to be at TRL, I think around 6 in October of this year. In terms of Luna and what we're doing here in this accelerator is the overall ambition of Orbit Fab is to build that in-space propellant supply chain. So we want to be able to use fuel derived from moon materials, for example, and sort of build that logistics supply chain, so be the distributor of that fuel. And one of the first steps we want to do is we want to sort of demonstrate that in space. So demonstrate Rafty in moon dust environment with varying gravitational forces. We want to demonstrate that on the moon and sort of automate that fluid transfer. So that's sort of what we're utilizing the accelerator for.
Okay, so I'm Luca Celiento from Man Electric. I'm one of the co-founders and the COO. Man Electric is a Luxembourgish company. We started our operations about 7 years ago here in Luxembourg with a clear target in mind to develop in-situ resources utilization. So now you are here, so you know what we are talking about. Originally, our idea was to tackle one of the biggest issues of the future, let's say, offer exploration, which is basically how to produce energy on the moon using in-situ resources. And during the years, we managed to demonstrate that it's feasible and possible to produce solar panels from lunar regolith and from, in general, low-value feedstock. So something that was originally a pure space idea was later turned into something that could be also used on Earth. And more than that, we managed also to kind of identify potential dual use case. Of course, dual use case is a bit confusing these days because of all defense space ambiguity today. But we really thought that the same technologies could be also applied for terrestrial markets and terrestrial industry. And later, we managed to even further find a place for our IP into other domains that are traditionally, let's say, not touched by space. Like, for instance, our work on extraction of resources on the moon turned to be a perfect case for alternative ways of producing metals on Earth without CO2 emissions, with lower energy consumption, and potentially have a disruptive effect on traditional industry and changing the way how metals are produced on Earth. So in that sense, Mana is capable of working on technologies that, again, are originally thought for being used for space, but we always try to find a way for placing them into the traditional industry, making sure that we are, while the lunar market is developing, we can still try to attract some kind of constant revenues from the terrestrial industry. An example is one of the two products that we are currently spinning off. One is, as I said, the assistant for a technology for producing green silicon, so silicon without with lower CO2 emissions compared to traditional industry that is based on carbon-thermal reaction, with a lower energy and less, let's say, societal issues which are coming from very unfair industrialization in China, for instance. And the other problem that we are tackling is also the production of solar panels, which can be kind of delocalized by putting solar panel infrastructures, manufacturing infrastructures into shipping containers, and then shipping them in the locations where you want your solar panels to be installed. This way, you are also bypassing some of the issues that are today, let's say, a problem for the industry, because with tariffs on Chinese production, which is monopolist, today you have a possibility with our product to produce solar panels everywhere. And in that sense, we have something that is anyways deriving from all the R&D work that we have done. And we are approaching to new project development with a philosophy in mind of spinning off technologies for Earth. So every time that we find something that could ideally work in space, but at the same time could also be applied on Earth, we try to spin off and create from there something that could somehow help the terrestrial industry.
Thank you. Yeah, my name is Keval Dattani at Space Power. And yeah, we do power in space. And so trying to find that dual use, the Earth connection, can be a bit tricky because we focus on photonics, optical power transmission, and the air and atmosphere is a real big headache. So that was one of my first decisions why I really wanted to focus on space. And then really trying to think about where do we fit in with the Earth ecosystem. It's really around data. How do we get data from space? And the increasing demands of data on satellites, on different instrumentation, and the resolution is where we start to see that every time you need to flip a bit, you need a bit of energy. And so as we're starting to go up from kilobits, hundreds of kilobits up to gigabytes, there's going to be a pressure here, and it hits you three ways: on collection, processing, and retransmission. And so that's where we see a really strong angle in the trends in terms of why we need to start doing these things now. And carrying on that thinking ahead kind of strategy, it was when we see the Lunar Resources program, you need to have power beaming for excavation and exploration. You need to go find all the good stuffs in permanently shadowed regions where the sun has never shone before. So when we depend on sunlight so much, what are you going to do when you need to explore these areas? And so power beaming for me is an obvious consequence. But in 2023, when we started to do a study about the moon, and I realized how little I really understood about the surface and the atmosphere and the environment and lunar dust. And then I started to realize, actually, it's going to hit my two most important components: my radiators for my heat rejection to keep my lasers cool, and my photovoltaics to help get and generate the energy. And so there's no point, as I see it, to do any power beaming on the moon, especially on the surface, if you can't get rid of the dust. So we're developing this kind of system within this program, which is using technology proven for terrestrial use. So we found, so there's a poor guy out in the middle of the desert cleaning mirrors for solar concentrators with water. And I think it was just the ridiculousness of how scarce water is and how much they were using to clean these mirrors. And so they looked for a different alternative, and the alternative was plasma. So they managed to basically go 50-50, half the water usage, but it's not commercializable because it's so expensive. But then the resources and the equipment that we have on the moon is so expensive, there's actually a use case. So all of this is a technology transfer to take what we've got for Earth using sand, develop this within the temperature, especially the dusty thermal vacuum chamber that will be online in 2026, and really start to develop what we know, known plasma with sand, transition that into lunar regolith simulant, and then start to adapt the plasma to then work with the resources that we'll have available. And I'm hoping that you're going to have plenty of waste oxygen, which blew my mind when I first heard about it. So I'm glad you're doing what you're doing. And I think there's also a lot of cross-collaboration across the group, which I find very interesting.
Thank you. So as you can see, there is quite a diverse set of companies: energy, manufacturing, refueling. Let's dive a little bit more into one aspect of these Earth, low Earth orbit space use cases and applications. So the technology angle. To try to simplify, there are potentially two paradigms. One is related to a narrative where a technology that you develop for ultimately a moon application go through a technology development where you test first on ground, in terrestrial environment, then you sometimes move to low Earth orbit, and then you finally get to the lunar environment. And this is a sort of pretty linear narrative from a technology standpoint. But you also have dual cases where you have technologies that perhaps don't have anything to do with each other, but they sustain the business pretty nicely. Maybe the most famous example is SpaceX and Tesla. You have two businesses that they don't particularly share the technology and what they do, but one sustains another in terms of one being successful and revenue generating in short term, and the other one has a longer term vision. I would like to get from you your take on this. So is it then linear, the development? You're following a path where you go from terrestrial, low Earth orbit, and then the lunar environment? It's a little more complicated than that. You realize at a certain point that the technologies of the application are diverting pretty much. And how do you discover that? How do you manage also in terms of teams and resources? Because if the technologies are different, you need to keep different vision, different way of managing the technology development. So it's a pretty broad angle, but I would like to hear a little bit more from each one of your stories. Maybe I'll start with FiberCode.
Okay. Yes, thank you. It's a great question, and I can say from a FiberCode perspective, linear is not what we do. It's much more all over the place, to be completely open here. In our case, we don't have the issue that our technologies don't fit to each other. So the base principle of manufacturing fibers is pretty much similar, and what the moon applications allowed us is to really rethink how we spin fibers, so the basic principles of how is it done, because up to the point where we started to dabble in space, we used existing equipment that was out there. And then with the learnings that we had from establishing our own spinning methods that have to be smaller and much more automated, we learned so much that we then started building our own spinning lines also for terrestrial use cases. So we took those insights, use them in producing on Earth, and then those again are now going to the new version for the moon again. So we have a lot of synergy in there, and it helps us because the issues that we face in a space environment are the same issues that we see coming in the Earth environment, which is automation, making it smaller and more flexible, like containers that can ship to my customer. Those are all things that we see happening and where we can leverage both sides of the story. So at FiberCode, we do have different teams. We have different people working on different issues, but we link them closely to each other to learn. And in the end, it's first principle thinking. If I have a great solution that is lean and affordable and can produce cheap fibers in both environments will win. And this is our mindset. We don't think that we need to be expensive in satellites or on the moon or on Earth. We need to be as cheap as we can so that we have a broad application so we can help many, many people in all environments.
Okay, thank you. So in your case, it's more of a closed feedback loop between space and Earth application. Okay.
In our case, it's more linear. We developed the technology from the very beginning. We didn't rely on any research or academic paper, or actually, we obviously were relying on what has been developed and what other companies are doing. But this was rather convinced us that they're not following the optimal path. So we are quite courageous, I would say, to think about more optimal way of developing this technology, because we started from the assumption that if we want to create optimized a tool that works perfectly in space or as good as possible, we can't take terrestrial hardware and adapt it for space, because it will still has the same limitations that it has on Earth. Or on Earth, maybe it's not a limitation that it's, for example, creating heat during manufacturing process, but in vacuum it is. So from the very beginning, we increased the risks. Increase the risk that if we fail, we don't have any other application on Earth. But beyond, in space, we are super versatile, and our technology can develop in multiple directions and be applied to multiple use cases further down the road. So we are starting from a solution dedicated for satellites, printing the simplest structure that we could think of, cylindrical boom. This is the first structure we want to print in space, starting from Earth orbit. And then when it comes to the moon, we want to take the very same printer and adapt it for lunar environment, and to integrate the raw material with lunar regolith. So this is our thinking. And then every next step will base on the previous one. So we'll apply all learnings from the current step to the following one, increasing number of applications it can serve, number of use cases where we can use this technology, and obviously also increasing the complexity of initially very simple hardware.
Okay, no, thank you. So in your case, instead, it's more linear, and there are an increased set of challenges that push the technology to be more efficient, and perhaps then it come back on Earth to be applicable in multiple cases.
So in our case, I feel like we're a little bit of both. I'd say, you know, sometimes I would say that we do quite a lot of development work parallel. This is super versatile. So Rafty, what we're sort of developing it as is, you know, you've got your low pressure. We're already developing it for different propellant types. It can also, so essentially it's a fill and drain valve. So every satellite or space vehicle will have a fill and drain valve to its prop system. And that means it can also double up as an on-ground refueling. So on Earth, we can do that before launch, as well as doing it in orbit. In terms of the lunar environment, I would say that, yes, we've sort of done the on-ground testing, then we've done, you know, we're doing the in-orbit testing, and then, yes, we'll go on to the lunar environment. But it's different in the sense that the dust is something that could get into our prop systems, for example, or specifically around the robotics. So the active side, when it's actually grappling on to Rafty, for example, how exactly is the robotics going to work when you're doing it in a lunar environment where, yes, of course, there's dust, but then also the gravitational pull is completely different. So how exactly are you going to sort of operate grasp in that way, which is the active side. So that's a little bit of learning that will be unique specifically to lunar. Having said that, though, the automation side, the robotic side, is again something that we're doing already, which is going to be in orbit, right? So a lot of things are, you know, developing like parallel, as well as us sort of developing this for lunar. But I would say that, yeah, there's with this being as versatile as it is, that's what we want to do. We want to make it as easy for customers to sort of implement this onto their systems.
Thank you.
Well, on ours, for our technological development, you have to imagine that the approach is slightly different from, let's say, the traditional space industry, because our products, they don't look like traditional space products like a satellite, for instance. They look like more, if we talk, for instance, about oxygen extraction or metal extraction from lunar regolith, we are talking about more like a reactor that is similar to what is generally used in industry for metallurgical production. So in that sense, we take full advantage of this situation, and we develop products that are generally kind of ground demonstrators, where we might potentially implement, let's say, technological solutions that are taking into account the difference in the environment, so vacuum or the presence of dust, these kind of aspects. But in principle, the same product can operate on Earth and can operate in space, of course, with some small differences due to a different use case or different, let's say, performance metrics. And in that sense, where the difference, let's say, the initial R&D, both for Earth and space, they are kind of converging at the beginning. Where the divergence happens is when you start thinking about turning the technology into a product and thinking about how the commercialization. In that sense, the metrics that you use for judging if the technology is viable for your use case are different if you are talking about the space product or the terrestrial product. If we talk about the space product, maybe you are looking at, I don't know, the mass, the power, the usual suspects, or in our case, how sustainable is the process for long-term activities on the moon. When you talk about the terrestrial technology, you are more looking at other aspects like, I don't know, life cycle assessment, cost assessment, the placement into a market, which are aspects that are more relevant when you talk about a terrestrial product. And that is the discriminant then for what we call the spinning off of the technology, because if certain metrics are, checking the boxes for their applicability, then you know that the very same prototype can operate also for space, and then you look into the scalability and other aspects. But if you already see from the beginning that this is like a technology that cannot be transferred to Earth, we clearly don't invest other resources on that. So just to summarize, in principle, what we have is like a common use of resources for space and Earth. And then when we see that there is a possibility to spin off, we look for dedicated, specific resources that can help in developing further for terrestrial market.
Okay, no, thank you. So try to compare a little bit the last two. So for Orbit Fab is you keep the same sort of expertise mix. So you can do things in parallel, but essentially still a pretty heavy engineering technology development. While what you're saying with Mana is that as soon as the product has legs in the market, you realize that the mix needs to change, so you need to bring in more sales, business development, and that's what changed the need also of the management of the technology development.
Yes, essentially that.
Yeah, and I think this is one of the key parts for the design for us as well. We're really focused on being universally compatible, so one laser beam to charge them all, right? And it's great for space. You can have whatever solar panel you have, or any supplier changes you need to do, it's all available. And that's where my focus has really been. It's quite difficult, I think, with lasers in atmosphere. I can go outside and shine a 50 milliwatt laser up in the sky and I could go to jail if it flashes on an airplane. So where's the scalability and where's the action there? It's really, really good for everywhere else. So in this sense, it's really difficult for us. It's either really niche cases, so where there's no fly zones or things like that, but even hundreds of meters is really what I'd be committing to rather than trying to do anything too big. Maybe there's things for HAPS or drones, but I think there are the better methods, to be absolutely honest. And I'm trying to be quite conscious about, there are the pressures to generate income, get revenues. You become so much more investable as soon as you can do that. But then there's also the risk, the counter is that you actually drift off into something that might not be manageable for the team and the situation. And maybe the technology gets drifted away so far that you've lost your original kind of goal. So, you know, for us, it's all about the development. Leo, we see as a nursery. I mean, maybe needs a bit more tidying up, but it's a great place for us to test out, start to work with different customers, do try before you buy missions, once we're in flight, and then start to move towards the moon where we've got much harder challenges. But I think it's the fundamental, even Jakub and Tejas with your Rafti, it's really about that fundamental. If you make it useful, universally useful from the beginning, you keep your options open as you kind of go and discover where the use cases are. But if anyone does have a good terrestrial use case, let me know.
Okay, no, thank you. That's pretty insightful from all of you. And now I want to touch more on another angle, which is more related to the investment and the funding side. So I said at the beginning that perhaps the focus, the push, if I can say like that, of having companies emerging in the lunar space resources to find also terrestrial case was also related to have an appeal, a broader appeal to the investor community. But things are not that linear there either. So you have space-focused VC that maybe are pretty much on an investment thesis that focus on what's happening in space, how the lunar environment is evolving, and how a technology they want to, or a product they want to invest in is fitting into this narrative. And then you have probably at the other end of the spectrum generalists that just look at the market, the numbers, and then they try to understand which kind of potential, disruptive potential has a certain technology. I would like to hear a little bit more from your experience and your take on how to deal with this landscape. So the dual use case, although I agree with Luca, it's a little bit tricky to use this term because it's military civilian, but Earth space narrative, how useful it is in the investor community conversation, in fundraising. Is it distracting? You manage to get more investor into the conversation. You pitch it in a different way to different investors, trying to play more on one side of the narrative versus the other. I would like to hear more from each of you.
Shall I start? Okay. Good. So this is a great question again, and it's not a very easy answer, but I can share a bit of the FiberCode story because we actually closed a 20 million round in October last year, and the journey there was what you mentioned, the dual use aspect, and here I mean military, space, and civilian, triple use in that case, I guess, was a huge benefit for us in the fundraising process. So we showed a lot of adaptability and resilience, and there I a bit disagree with what you said before, because we didn't just singularly focus on one aspect, but rather showed that our material, our approach can work in many different fields and can adapt to a world in crisis. I mean, we've been 5 years now in pure chaos on Earth, because we were able to show that we can adapt from automotive use case to construction to military and even to space. Investors liked our approach very much. They saw that FiberCode is resilient, we can survive, we can deal with what is thrown at us. And we found, for example, New Space Capital, who invested in us in the last round. They saw that this flexibility and agility of ours can also be transitioned into space, and they saw this potential and supported us to move further into the space sector. So what I would say in that aspect is being able to showcase to an investor that your solution is flexible, has a broad applicability, and can be adapted to a changing world order as a startup where you don't have your product market fit. You're not a Siemens or a huge company that will be bailed out of bankruptcy. You have to be flexible enough to show that you can survive. Was a huge benefit for us. And our existing investors supported us. We get new investors from this. In no spot did they tell us that being able to work in different fields was a negative. It was always a positive. That said, staying focused is hard. So the pivots that we make are always focused on a certain specific area. We don't do 20 things at once. This would not work. but being able to pivot to what the market needs today, and today it's space and defense, is I think is a very important aspect. And investors, from our point of view, from our experience in the fundraising process, like that adaptability a lot.
No, thank you. So in your case, the versatility was really a key point, a key selling point, but you also had to balance it well with the efficiency because of the matter of the focus. So I feel that sometimes it could be a distracting point to say we can do a lot of things, how you're going to manage such a complex environment, but if the company is lean and efficient in addressing the different applications, then that's the right combination.
Yes, that's exactly right. So it's always the benefit of having a broad application base as well as the focus. That's completely right. And this plays a lot into what you just said. Your system works into many different areas, and it's the same. What's the name of the Rafty? So it's the same Rafty in all applications. And this is the same point. We develop fiber types. We develop spinning. They can serve many areas. So if you sell a fiber to a weaving, a construction, an automotive company, it's always the same fiber. We try not to have a lot of different types of fibers. Now with investment, we dabble into new materials, but staying focused on the core that has a broad flexibility is key.
Thank you. And for orbital matter, instead, what's the take?
Well, I agree with everything you said, but for us, it was a huge trouble because we don't have any traditional applications for a 3D printer. For the very same reason what I mentioned at the very beginning when presenting myself, my company. So we decided that in order to win the space market, we needed to invent totally new approach, new technology. So it doesn't make sense to apply it on Earth, the very same technology, because there's multiple better ways than putting a 3D printer into a vacuum chamber to print stuff, to manufacture stuff. So that was very hard to find investor who would share our vision, who would understand that we want to focus on space without building this, without limiting their investment risk and our operational risk, or our financial risk. And deciding not to have this like threshold backup, because that would be that would be the meaning of having the threshold printer in our case. And our vision is to disrupt the space manufacturing market and bring it to space and enable the scalability of structures, of things, all the things that we build in space, whatever it would be, if it's lunar infrastructure, space stations, much larger than the currently existing one, or even if we consider the satellite components like those beams, or later antennas and other parts. So this was our goal, and obviously we could do things at the same time, but and probably we could have find more financing for it, or secure financing quicker, hire more people, develop some printer for terrestrial use, different one. But I think the critical aspect that we are worried about is that if we found investor who seeks security and is not ready to take on this challenge and be with us on the road to achieve our goals and believe in our vision. We were concerned that such investor would force us into generating the revenues from this threshold use case, and then we'll end up as a mediocre company. So maybe successful, maybe generating revenues, profits, maybe even sold to the industrial investor, or making a IPO, making some money out of it, but that's not our dream. So it was more about our ambition and fulfilling those dreams with higher risk, but aiming for much higher reward and much more meaningful aim.
Okay, no, thank you. So in your case, it's more about we focus really on space, but then the point is to find an investor that is a lot more aligned with your vision. So that buys into that thesis, that vision of what space will become in the next few years.
Yeah, that's right. And it was super hard. So 99% of investors were actually asking us about revenues, about terrestrial use case, and so on. So anything that will start making profits, not even revenues, but profits sooner. But we are convinced that we'll eventually find someone that will share our vision, that will support us, and so far we are correct. I hope that we'll continue to be successful in finding such investors.
Thank you.
Quite a lot. Yeah, so I'd say, there's some luck in going first. Quite a lot of the stuff you already mentioned, Robert. But I would say that it's very investor specific. So if we're going from a more general investor, it's how you pitch the idea. So the way that we would kind of pitch the idea is relate it to Earth base. So think about a car. Like, if a car runs out of fuel, you don't want to get a brand new car, you refuel it. So we sort of sell this as kind of a petrol cap, for example. Space-based, again, it's a bit different. We'd go more technical there. And again, defense as well. So a lot of defense investors, they see a big benefit in what we do. They want to be able to maneuver with freedom and be able to deter different assets, to be able to sort of maneuver away from assets, things like that. So definitely they see refueling as very important. So I do think that there's importance in exactly how you pitch it to different investors. One other thing that's a little bit different is I feel like, especially with lunar applications, you will get predominantly space-related investors. If you want more general investors there, I guess the pull there is to look at what you can do within the moon that will benefit the Earth. So, for example, I don't know if you guys were there this morning. Interloon were giving a talk on helium-3, for example, and being able to mine that, like sort of harvest that from the moon and bring it back to the Earth. That's where people here would be quite interested in that. So, looking at how we can utilize the moon and space to help the Earth, help the environment that we're in as well.
Thank you.
So when we created the company Mana, the idea of having a dual use case, so both Earth and space, was a kind of the holy grail of startups, because you could get two markets with one unique technological development. So you are optimizing your resource usage, and you get two birds with one stone, two products for two different markets with just one investment. In the last years, we had to face the reality that investors want clear-cut cases. They want simple cases with very defined boundaries and very clear targets. And very often we heard from investors, but this space market, it's just a distraction. Why you don't just cut everything and you focus on your terrestrial product, because it's the one that is giving you revenues in the short term. But of course, on the other hand, our vision is space, is exploration, is sustainability. So why we should cut something that is as being the driver for the creation of the company? And on the other side, we hear from the space investors, you should probably focus only on space, although there is no space market. So how do you solve this paradox? There are two options. One option is, as we are trying to do, try to separate the two companies or to two, let's say, markets, space and Earth, and make sure that if you have a clear case for terrestrial investors, they know that they are investing in a company that is just developing something for terrestrial market. And I have to be honest, the moment we decided to take this approach, also discussions with terrestrial investors, although we know that investment on hardware is reducing with compared to a couple of years ago, it was much easier, and we came to easier deals with terrestrial investors. with space investors, the question is always the same. Where are the customers? And Mana, as one of the first ISRU companies in Europe, has advocated for many years, and hopefully we will try to get something out of this space accelerator to make sure that, like that ESA, for instance, might be a kind of first customer for the companies that are aiming for hard markets like the moon. You bring the example of Interloon. Interloon signed an agreement with the Department of Energy. If you bring back Helium-3, we will reward with something. Why we cannot take the same approach in Europe? And if I have a first customer that is like my target, because it's an agency, and I'm able to reach my target to go on the moon and produce oxygen or produce metals, can I get rewarded for that? And this way, I can also go to my space investors and say, look, we are clearly focusing only on space for this. We have a clear case for you. Can you support us in our venture for demonstrating that we are the first company that can produce oxygen or metals on the moon? In a certain extent, it's also a matter of creating the right conditions, creating the right structure that can support the startups from the incubation, the acceleration, and then later when they are ready to walk with their own feet, to have at least, some small support from the agencies, for instance, to help them in securing some private capital. Because today, if I go to a space investor, they will say, okay, I don't see a future for, a close future for lunar market. So that's why we really believe that on one hand, we should educate a bit investors on this dual use case, making them understand that it's an opportunity, not a constraint or a limitation. And on the other hand, it would be nice to have an ecosystem that is supporting, although we have complex goals and we have maybe medium long-term goals. Otherwise, we just stay on Earth. We don't have any, vision for the future. We don't think about all the sci-fi, idea of making humanity like an extraterrestrial civilization, and we just stay where we are. But this is, let's say, the exact opposite of progress. This is not what brought humanity to this point. We just have to be a little bit braver.
Yeah, I think that's it. It's risk and reward, right? And we're looking to the VCs who should be the guys taking the risk with their big portfolios and making those bets. And terrestrial uses is just a really nice hedge. So I think there are some areas where this is a great idea. I think there's a difference between, when we're talking about products and services and really thinking about infrastructure. The roads that we're using, the airports, aren't working on 5-year rates of return, but we use them. Where was the market before? And that's where we're really trying to find that. Actually, I think we need those bolder investors, and I think there is a bit of a problem when you talk about education. I think the spreadsheets are skewed. I think that's my suspicion. We're looking at, we do a miss. There's a comparison between Apollo missions and today. Today we do a mission for about 150 million. I think the equivalent was about 100 times per Apollo mission, and not all of them landed. Some of them came back, and it's this kind of skewedness that is kind of giving us, or the risk perception of what space is, I think is a bit off. And it's trying to find where is the infrastructure money going to come from if the VCs aren't going to be there, and it's trying to find those kind of use cases to help us build things, because Jakob, you're building something that's super useful out there. You don't need to do 3D printing. We've done it on the Earth. It's fantastic. It's a new case. It's a new area, and I think it's a bit, when we talk about those dual uses, and actually more in the military side, and where you might be able to also get rediverted into a totally different angle that you expected. But that's where there is that appetite, because if there is already a market, then it's not a cutting edge technology or a cutting edge capability. So when we then start to see that interest from the defense side to then help us It's how do we make sure that we're still balancing it for the overall civilian use, which is actually where the massive money is. And when we talk about space, it's a huge opportunity. So it's risk and reward, and the people that can take that risk, I think, will be rewarded massively.
No, thank you. I think you all touched in a way or another quite a few interesting points. I mean, I think in general, the one that I want to take out is that I feel that sometimes not only in the investor community, but also in the agency and broadly, even in business, one issue when dealing with innovation is that we want things to be fully predictable. So I invest in something, I expect a certain X return, and this is what I want to buy. But especially when you're pushing the limits of technology beyond what you know that you can do, there is an expectation that you can unlock benefit that you cannot clearly see at the point where you start, but they are there. The classical example is the Apollo mission that generated the X-ray that we use today. They didn't know before. They couldn't know before. It's just the sheer willingness of going beyond that line that allowed this. So I think we need to find a better balance between the two, but it's genuinely difficult because there are some markets that are perhaps more ready. Low Earth orbit for refueling, it's a nice stepping stone because it's moving and it could be a good testing ground before going to the moon. In other cases, it's more pretty much a focused, we want to enable a new market on the moon, but we need to be focused and have a longer term vision. So it's a work in progress, but we are getting there. So we took a little bit more time than what you expected. I just want to finish with a quick, super final question, which is related to imagination and pushing the question to beyond what we can see. So a snappy answer from each one of you about what is your most unexpected prevision for the next few years in space resources.
Okay, I'm going to kick us off. I'm not sure if it's so unexpected because I heard it twice here, but I think in 5 years from now, we're going to have a panel sitting here focused on securing and defending and using defense funds for space resource utilization. This is going to be the topic where our world is heading, and I'm pretty sure that we can leverage that money to really drive our innovations like it has happened in the past decades in many other fields.
I think I'll be half optimistic, half negative about it. So I would say that it will clarify in 5, 10 years, in a few years from now, which use cases, which technologies make sense and which not. So market will, I believe, mature, and it will be much clearer for everyone what makes sense and what not. Also for investors, so something that we just discussed.
I'd probably say asteroid mining. So, well, if it can be done in 5 years, incredible. But that's why it's unexpected. Just in terms of, there is so much up there we just don't know about. There are so many resources up there. Like, we haven't discovered a lot of space yet. And being able to utilize any minerals, different things that we can get from asteroids and bring them back onto Earth, I could really see that being a potential market in the future.
Just a few observations from these 2 days of Space Resource Week. So we have this Space Resource Week after the announcement of the U.S. administration on cutting some budgets on, exploration and so on. Clearly, the general feeling is clearly not very positive because the idea is that it's a real shock for Europe right now. But if there is something that we have in Europe that is an excellence, is indeed ISRU, space resources. We should invest more, not cut investments on this. Find ways to expand this capability, because here in Europe, we have a system that goes from academia to industry, agencies, that is very well developed and made a huge progress in the last years. So I would simply be hopeful that whoever is taking decisions these days on what is going to happen in the next 4, 5, 6 years we'll take into consideration that we have a huge value today coming from huge expertise that we should probably expand and try to exploit more.
I think I see quite an optimistic new 5 years, and I think it's all about the race that we're going to go to the moon. I see the cross collaboration internationally that's actually going to start growing, and I think the US will come back as well. And it's going to be the same Brexit story. You can't do everything alone anymore. And so I think what I see as the positive is that as we all start to go to the moon, it's more the us versus them mentality will start moving more towards us, as in the Earth and the globe, and them being all of the dangerous things that are out there that we're going to start finding out and discovering. And so that's where I see actually a bit of a positive and a way that the moon can start bringing us together.
Thank you. And on this great positive note, I would like to thank all the panel members for this very insightful discussion, and the audience for listening in. Thank you. So we'll recharge the battery for a little bit, and then at about 4, maybe 4:05,